Okay, here is the next example. So in this example, similar to the other examples, we are finding transfer function y over u from this simulation diagram. So if you look at this simulation diagram here, I can see z2 and 1, these two are in parallel. I can combine them, make it as z2 plus 1. Okay, and at the same time, this feedback h2, usually we draw the feedbacks in the down here and forward paths up here, but in this diagram he draw the feedback up here. So what I did, I put it down there. Okay, now here I also moved this takeoff point from here to here. It's not going to make any difference because the signal anywhere on this line is constant. Okay, now what I did, I combined this feedback elements, which is going to be 1 minus, since I have plus here, it must be minus 1 over 1 minus h2, and I combine these two. It's just multiplication, so z3 plus z2 times z3. Now I need to move this takeoff point. So if I move this takeoff point from here to here, that will help. Okay, so say for example, the signal here is a. What is the signal here? It's going to be a times this whole thing. Okay, so what I need to do, I need to divide. If I move this from here to here, so after the block, if I move the takeoff point after the block, then I need to divide the feedback with that whatever elements in there in that block. Okay, so that's what I'm going to do. So it's going to have z1. Okay, that's z1, and I have 1 over 1 minus h2, and then I have z3 plus z3 z2. Okay, now what I did, I'm going to move the takeoff point here to here. At the same time, I have h1, so let me put the h1 here. That h1 looks like negative feedback, so that's a negative feedback. So it doesn't matter whether I move it to this point or this point, because the it's the same line. The signal anywhere is going to be the same. So this feedback is also negative feedback. We'll end up having 1 over z3 plus z3 z2. Okay, so this is u and this is y. Now these two are multiplication, and then that's a feedback, that's a negative feedback. So I'm going to combine those two. So that's going to be z3 plus z3 z2 over 1 minus h2 over 1 plus h1 times z3 plus z3 z2 over 1 minus h2. Okay, I'm going to simplify this in a minute. Okay, and then I have c1, again this feedback, 1 over z3 plus z3 z2. That's our y and u. Now once we simplify this, here I have the denominator, these two must cancel out, but before canceling out you have to do the LCM here to make this go away, or to make this 1 minus h2 as a common denominator. So I'm going to multiply this with z1 too, so it's going to be, correct me if I'm wrong, z1 z3 plus z1 z2 z3 over 1 minus h2 plus z3 h1 plus z2 z3 h1. Okay, now this whole thing has a feedback that's a negative feedback, I believe. Yep, you can see there, it's a negative feedback. Y and u, it's going to be 1 over z3 plus z3 z2. Okay, now since I have negative, it's going to be plus. Say for example this is x and this is a, it's going to be x over 1 plus ax. That's the formula for this. So it's going to be, let me pull z1 out so that some of them might cancel out. z3 plus z2 z3 over 1 minus h2 plus z3 h1 plus z2 z3 h1. Actually, okay, yeah, I cannot do that. Divided by 1 plus 1 over z3 plus z2 z3 times z1 times z3 plus z2 z3 over 1 minus h2 plus z3 h1 plus z2 z3 h1. Okay, now these two get cancelled out. Okay, and once I multiply this denominator on this side, this and this get cancelled out. So this y over u equal to z1 z3 plus z1 z2 z3 over 1 minus h2 plus z3 h1 plus z2 z3 h1 plus z1. Okay, that's it. That's our transfer function. Thank you. I'll solve one more example in the next video.